Yes, it is. Okay, so I have that magic box for the presentation. So, well, it works actually. I'm Benjamin. I work at IRT, IRT Saint-Exupéry in Toulouse. I will explain a little bit what it is, what we are, who we are, and what we do. And I'm currently project leader on the cybersecurity for space systems project in IRT. I'll tell you also about what the project is. Agenda, who we are. I mean, we're pretty new or we're not new to the space industry, but we're new to CYSAT. Obviously, this is the first time we present something. So I'll tell you about who we are, what we do in AI. That's a key area of expertise in RIT. I'll tell you about CSS, the project, and also a new program that we're trying to launch, and for which, hint, 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 we're looking for partners. Okay, IRT, who we are. We're a private research foundation. So we're not a startup. We're not a commercial company. We are a research foundation. We're sponsored by the French government, and our business model is basically to take technological roadblocks from our members, founding members, and our industrial partners, technological roadblocks on their R&D roadmaps, 1, 2, 3 years ahead, partner people and lead project to remove those roadblocks. Okay, that's what we do. So we're sponsored by the French government, and we linking with academic research and laboratories and other institutes. We remove those roadblocks, and we try to bridge a gap between the research institute and the industry. That's what we do. Founding members, very important, CNES, Airbus, Thales, Safran, all the big guys in the aerospace industry in the Toulouse area, okay? Because, yes, we are based in Toulouse. I didn't say it, but it's kind of obvious, right? Well, hopefully. Areas of expertise, okay, no, it's not what I wanted to do. Okay, there was supposed to be something up there, but that's okay. 70% of IRT, I'm going to say ERT because, you know, the translation doesn't work. 70% of what we do in ERT is about putting in the air a plane with zero carbon footprint. I mean, to make it extremely short. So that's why we have expertise in high voltage energy, because I mean it's going to be electrical, of course, advanced manufacturing processes, optimization processes and methodologies. 30%, that's the green piece here, is about numerical engineering, non-terrestrial telecommunication, artificial intelligence, other numerical engineering type of activities. That's 70%. And I work in the AI team. You can see numbers. Okay, we're about 350 people, and a mix of founding members, a mix of industrial partners, and laboratories. AI, what we do in AI. You're talking about 45 people. Okay, so that's, I mean, outside of Paris, I mean, it starts being significant. Of course, I mean, there is, the Paris-Saclay area, which is pretty much state of the art in France, obviously, and also in Europe, and probably worldwide as well. Outside of Paris, we are one of the biggest platforms in AI. Not by ourselves only, of course. We link with, again, I mean, our founding members and also the academics. Okay, IRT, that's, I need to talk about them because, I mean, first, they're nice guys, they're smart, and we basically work in their offices as well. So, I have to tell them. You have 4 artificial intelligence institutes in France. IRT is one of them in Paris. They are reviewing the framework, the budget, and we link with them 8 chairs, 40 researchers, 25 PhDs, so that's a significant research activities. We also have a program it's called DEAL. It's been on for basically 6 years now. It's a joint program with Canada, MILA, for those who know them, about trustworthy AI. And Confiance AI, that's the big French program. It's coming to an end this summer. It's the wave number 2 is coming in September. 7 work package, and IRT is leading 3 of those out of the 7. So you're talking 45 people in AI. And I mean, going back, okay, the goal is to provide operating guarantees for embedded and trustworthy AI. It's a little bit long, but every word is important. Operating guarantees. You need to be sure that your model, your AI, is going to operate predictably within boundaries that you understand, that you can explain, and that to people, and that you can guarantee from a mathematical point of view. It's got to be embedded, of course, because in the end it's going to be in a plane, in a satellite, or another critical system, and of course trustworthy. That's a big word. That's a buzzword. Okay, you need to trust AI. Blah blah blah. Okay, it requires some math behind it to be sure that it works. A couple of projects. I will not go into details, but give you a little bit of overview. Multimodal learning for image retrieval, satellite observation images. You get a prompt, okay. And I'm missing lots of stuff here. Okay, there's suppose. Okay, for example, you're going to prompt. Okay, I want an image with an arbor. Okay, you enter the text, and it's going to pull out those different images. That's AI. Okay, that's not rule-based. Synapse and Minds. That's optimization of planning of image capture, depending on what you want to do, on the schedule, on the new priorities that come up, and how do you optimize based on the cloud coverage and that type of stuff. How do you optimize the image capture? This one is the team has put into satellite an AI model. Not talking about GPU. Huh? I'm talking about a trained model into satellite for inference purposes only. So that's a defense project. Not supposed to talk about it, or they will kill me when I get out of the room. So, but it's linked to what's happening right now. NVIA, another project. We're talking reinforcement learning here. Okay, so reinforcement learning, it is still quite fashionable. You see AlphaGo, you see protein 3D construction stuff. That's one area of machine learning that's kind of sexy, actually, where an agent is going to train and learn the best policy and how to run a dynamic system. The idea here is you have a simulation environment. Okay, you're going to train your reinforcement learning model. It's going to work fine, and then you move to the real world, and suddenly, boom, things happen that you did not anticipate, or that you should have, but you didn't. But anyway, so that the simulation to real type of problem. It's called also domain adaptation. In fact, it's a little bit different, but it's the same idea. How do you move to the real world with operating guarantees? Runway detection. I'm missing half of the slides again. I mean, it's incredible. Automatic runway detection with people from Airbus. Okay, it works quite well. It's real time, and you're going to detect the runway. And it works quite well. On the bottom, you'll see the team is developing open source libraries. One is about explainability, mostly on images, but not only, and also on robustness. Okay, so that's open source. You can download. It's pretty well done, actually. Here you go. CSS. How am I doing on time? Yeah, halfway. Okay. Cybersecurity for space systems. Okay, what do we do on this project? Okay, 6 partners, 3 million euro, 36 months. We're pretty much finishing the first year. The team is fully staffed right now. We're getting there. First thing, apply cybersecurity methodologies to space sector. Okay, so I will not go into that. Okay, I'm surrounded by specialists, outnumbered, outsmarted, so I will not go into that. This is your job. That's fine. But that's where we're working. We want to work on the specific roadblocks from a technology standpoint for cybersecurity in space. So it's kind of a niche. Okay, we're targeting this. Those two, as an example, state-of-the-art AI solutions. When you look, I mean, you do research on Google, on Archive, on AI for cybersecurity, and you have enough to read for the next 2 centuries close. I mean, it's huge production on that. How do we, what makes sense? Okay, what's the state-of-the-art solutions? What makes sense from a cybersecurity perspective for space systems? We're beginning to have clear ideas on that, even though we're not done yet with the state-of-the-art reading. Spatialize CTI and OSINT. That's a big one. There was a very nice presentation from a young lady yesterday, Clémence Poirier, I guess, and she said, there's no specific APT for space. I mean, there's no specialized group that goes after space systems. Kind of true, but still, I mean, it's not kind of true. That's true, but we're trying to build a pipeline of CTI and OSINT specific that we can leverage and apply for space threats. It's not easy. And of course, identify use cases. I'll go into that as well. The big thing for us is new technologies, cyber range and AI. We have the machine. It's been delivered. Where we have 2 people working on setting up the cyber range and the software. Where they are coding a small constellation. I think we're talking 10 satellites. Okay, it's not a big thing, but still, I mean, anyway. And the idea is to emulate an LEO constellation on a computer, on a cyber range, so you can run attack scenario, and test defense strategies and as well as AI. And we have also one partner, Gatewatcher, who's working on deploying and specializing their solutions to what's specific for space, including the protocol, CCSDS and stuff like that. So we're starting. I mean, we're pretty much on the way. This one, okay, that's your job. I mean, you're doing that much better than we do. But I mean, we want to target what's specific for space and deploy new technologies on it. We pretty much finished the risk analysis. EBIOS risk manager with the help of and the leadership of CNES and Thales Alenia Space on this one, and we're working on sticks modelization with AI. I'll talk about this a little bit. Okay, that's the big thing. AI. That's the risky part of the presentation because that's my comfort zone, so I can spend probably 2 hours on that, and I don't have the time. And you don't have the patience, so I understand that. There is a lot of things to do on AI for cybersecurity. I'll talk a little bit about that in details. And digital twin, again, a buzzword. A big computer, a model, a cyber range, and we emulate the Aussie stack from layer 2 to layer 7. And we want to run attack scenario from the EBIOS risk manager, risk analysis, and test stuff. Okay. AI, I'll go into that. AI for cyber. So that's CSS, and we say, okay, our founding members are telling us, cybersecurity is all over the place. It's not only space; it's all over the place. You have an expertise, experience on AI. Help us with cybersecurity, and take on roadblocks that are not proprietary, that we can share with possibly with other industrial partners and possibly competitors, and lead project to remove them. So we're thinking about this one, AI and cybersecurity. This I talked about. We have CSS, and we want to go beyond. Okay, so that's AI and cyber. What do we want to do? Very nice presentation here from yesterday. Yesterday from Thales Space on cybersecurity and AI. Yeah, there's a big hype. Okay, everybody's talking about that. AI, cyber, blah blah blah. Okay, what does that mean? AI for cybersecurity, of course. Two things is you have a defense chain today that you can augment and whose performance you can enhance with new tools. And that's a big thing. Cybersecurity of AI. 90% of the companies I talk to are telling me I am going to deploy generative AI, ChatGPT, Llama 3, whatever, into my organization to augment the productivity of my people. How do I secure that? I don't have the answer. Okay, and there's a lot of research going on right now, but it's a big thing. You're increasing the attack surface of the organization when you deploy generative AI, especially if you supply a foundation model that's open source. You don't know exactly what it's been trained on. There can be backdoors. There can be prompt injection patterns put into it. I mean, lots of things can happen, and you have the risk. Again, I was in the presentation from the task people yesterday of data leakage and that type of thing. So that's a big thing. Lots of research activity on this one. Offensive AI. It's not War Games. It's not Terminator. But yeah, that's you increase your kill chain performance. Okay, new phishing patterns, phishing, quishing, voicing. I mean, whatever. Okay, but AI tools to make sure that you can lure people and into surrendering passwords and that type of thing. The companies I talk to are not really into offensive AI. Maybe they are, but they don't tell me, and they shouldn't, and they don't, and that's okay. But we think that it's good to know. It's the same thing as pen testing. Okay, or ethical hacking. Okay, you need to know what the bad guys are doing and how they work, so you can work against them. Okay, that's the last one. It's a little bit buzzy. That's what I want to do in that new program. So we're talking probably a team between 5 and 10 people, roughly 2 years. Not much 2 years because 3 years in that field is close to eternity. So 2 years is probably the maximum time frame that the industry is willing to look at. And that's okay. Defensive AI for cybersecurity. I'll go a little bit into the bold thing. Yeah, I got 1 minute. Alerts qualification. The SOC people are telling us, okay, we are swarmed with false positives. You can do whatever you want. You can have 99% performance on your data test or on your data set, etc. But in the end, I got 30-40% of false positive and a high rate of burnout on my analysts. Okay, so help me qualify the alerts. Explain why your system is raising alerts. Okay, that's going to help me do the triage. Advanced techniques for anomaly detection. Cybersecurity is anomaly detection. Okay, it's easy from a machine learning perspective to say this thing is an outlier. It's not part of the probability distribution. Well, it's easy. Yeah, it's doable. But in the end, is that relevant or not? Is that a suspicious activity, or is that Mr. XYZ that's logging on his computer from his remote vacation place? In case it's unusual, but it's not really suspicious. It could be, but anyway, you get the idea. Generative AI for defense. Okay, I mean, Gen AI is allowing people, okay, to really contextualize and give context to alerts. Ensemble method for different timescales and large data sets. Ransomware is going to crypt your mass storage within milliseconds, and an APT is going to go into your system within months. Having an AI able to understand the full timescale across all the data sets, my opinion is not going to happen anytime soon. Okay, that's complicated. I mean, AI will help people in the SOC understand the defense, will increase the defense performance of the organization, but will not replace people. I mean, it's a chain. It's complicated. But anyway, we have ideas here. Natural language techniques. Okay, I'm way in red. Cybersecurity of AI, that's a big thing as well. Potential use cases. I mean, we're looking for partners. Okay, we want to make sure that we're not going after the shiny algorithm that's going to help us gain 1 or 0.2% of performance on a toy data set. That's not the idea. Okay, we actually want to solve problem for industry. So we got ideas, okay, and we're pretty much open to new ideas. That's it. I'm 2 minutes behind. Anyway, if you want to join either CSA, Cybersecurity for Space Project, or the other one, CyberAI, you can give me a call. You can reach me. You can text me, whatever you want. Okay, but anyway, I'm available to discuss. Okay, that's it. I'm done.
Thank you, Benjamin, for the talk. Now it's time for some questions. Okay, we have in-room questions.
Thank you. So I wanted to ask, one of the things that you mentioned was that the MITRE ATT&CK framework is something that you want to spatialize. Correct me if I'm wrong. The MITRE ATT&CK framework is something that you also want to spatialize. Do you plan on using something like the Sparta framework, which is already space-based?
Yeah.
Yeah. Okay.
Yeah. There is Sparta. There is PLC from a cybersecurity standpoint, and from an AI standpoint, it's MITRE Atlas. I think. It exists. Yes. No, we're not going to redo stuff that exists already. No.
Yeah. No need to reinvent the wheel.
No.
Okay. Thank you.
Any other in-room questions? Okay, then we have a couple online. Yes. Okay. From John. The mega companies are investing billions in the AI arena. How can Europe industry provide value or innovate and build value in this space, with our relatively small budget and timeline?
That's a tough one. Thank you, John. I don't know. I think the approach is different. I mean, people are used to saying, the US innovate, some other countries copy, and Europe regulates. I think that's pretty much it. I mean, where AI Act is coming into effect, so we're still working on AI, but with a different view on compromise between innovation and regulation and ethics. And that's pretty much where, I think we need to be comfortable with that. Don't think we have the choice anyway. But for me, that's a big difference. But yes, I agree. I mean, the budgets are different by orders of magnitude.
Okay, thank you. We have another question from Milenko. How are simulating the space and the ground segment? Are you using actual ground system software and industry standards for simulation like SMP2?
Okay, we plan on simulating space and ground segment, yes. The question we have pending is, are we going to simulate user segment or not? That's a little bit of a Pandora's box. So that's the big thing that's being discussed within the team right now. Are you using actual ground system software industry standards for simulation like SMP2? I don't think so. I need to talk to the guys, but no, I don't think so. So far we're using I think that's NAS Cube. Let's see. A lightweight satellite simulator from NASA.
Okay, we have a second question from John. AI generally needs large dataset to train. There are often out-of-limits alerts and alarm to distinguish normal problems compared to adversaries in measure challenge. How did you approach this? Any recommendation or challenges that you encountered?
The approach is to basically not try to answer the question too much. I mean, beyond the. I mean, what I mean by that is whatever ML AI model you're going to use is you're going to come up with a probability of that event, being part of your distribution or not. So you're going to have a number that tells you, okay, this is an outlier. Now, the nature of the outlier is hard to define through ML. So the way around that is to provide information context to the humans in terms of the explanation. So the challenge is more on explaining the outlier and providing context information more than having a model trying to tell you this is suspicious or this is not suspicious. That's our view.
Okay. That was the last question. Thank you again, Benjamin, for the talk.